Today we're going to talk about triangle proportionality theorem, and we're going to talk about similar triangles. We're taking a step back from our 30, 60, 90, and we're going to just talk about some relationship on these different triangles. First thing we want to point out is an altitude of similar triangles. When we have an altitude, if we have an altitude from the hypotenuse of a right triangle, it forms two triangles that are similar to each other and the original. So if you'll look at this and see what we're talking about, we have a right triangle right here, and we are dropping an altitude. Remember, an altitude is a perpendicular line that touches the bottom, and it's used to measure the height of a triangle. But what we want to emphasize is when we have this happen, we actually have three similar triangles that are created. What we can see is the larger triangle is similar to this smaller triangle here, the red one, ABD, and then also similar to the triangle BDC. So these are all similar triangles. All we have to do is recognize which is part of one another. So let's take a look. We've got a little example we can do real quickly here. We see on the small triangle, we have the small side. And we also have the medium side. Now we don't have proof that this is a 30, 60, 90, so we cannot use any of our ratios. But we can use Pythagorean's theorem to find the measure of angle Z. So we end up with 4 plus 16. The measure of Z is the square root of 20. And we're going to leave it as the square root of 20 because that's actually going to work in our favor a lot of times. So we'll put it there. So Z is equal to the square root of 20. I'm going to get the decimal answer just for myself, just so I have an idea of what we're looking at. And I also like to know if my answer is reasonable. And it is 4.47. And that makes sense because my hypotenuse is the larger side. So what we recognize is on the large triangle, the square root of 20 is the small side. Square root of 20 is the small side of the large triangle. And we saw that we had a ratio from small to medium of 2/4. So to go from small to medium on the large triangle, it would also be doubled, but we're going to set it up as a proportion today just because some of these numbers you'll want to set up as a proportion. It may not be doubled. It may be, 3/5, something that you're not as familiar with. So we divide by 2 here, and x equals 2 square root 20. So that's how we go from small to medium. It's a 2-to-1 ratio. And then lastly, we see that the value of x is the medium side of the medium triangle. So we have a medium triangle here. The yellow I'm trying to draw. And on this, we have the small side, 4. Do this in a different color. Small side of 4 and an unknown side of x. And this is going to be comparable to the small side of this and the medium side of that. As long as we compare, see, I've got small over medium on both triangles. So this proportion is going to work out for me. And of course, it's a 2-to-1 ratio, but I'm going to solve these out anyway. So this measure would be a measure of 8. So we just continue that, and that's called a scale factor as well. We can see the small from one to the small to the other, and that's called a scale factor. So we have parallel lines here. So when I have parallel lines, what I've created is similar triangles. Remember, similar, not congruent. So the sides are proportionate. We just need to make sure that we're comparing comparable parts. So I'm going to call it the small triangle, and then the additional part. It doesn't matter what you call it or how you do it, as long as you reference. So we can do this a couple of ways. We could say 45 is to 30 as 27 is to the unknown amount SW that we're searching for. That is one proportion we could set up. We could also set a proportion that compares 45 to 27, and 45 is to 27 as 30 is to the unknown SW. And we could add up the sides, but we really don't want to do that. We're going to create equations that we don't really want to deal with. But once we set it to this proportion, I'm going to go ahead and work with the first one. Not that it matters, because you'll get the same amount. And what we're going to do is simply just cross multiply. So this gives me 45SW. You could have changed that to a variable. It probably wouldn't have been a good move, actually. And then we do 27 times 30, which is 810. And then in order to get the SW by itself, we divide by 45. And the side SW would be equal to 18 units of measurement, whatever ours are meant to be. And then always check this work to see if it actually makes sense. What I mean by that is 45 was larger than 30, just as 27 is larger than 18. And we could measure our scale factor on these to see how much of a scale this is just by simply dividing one side by the other. So like the triangle here that I'm highlighting in blue has a side of 45, and the other triangle is really this huge triangle. So the side that correlates to 45 is not 30, it's 30 plus 45, which is 75. So our scale factor between these two triangles that we have is a 60%, but it's a 3 to 5 scale factor. It's 3/5 of the larger one. So we can see on this one, similar thing happening to us. It's giving us parallel sides, so therefore we are creating a similar triangle, and they're wanting the value of RS. So we're going to set up a proportion, and remember, you have multiple options. I'm going to do this one because this is nice and easy. 25 is to 50. Well, that's a 1-to-2 ratio proportion, so we can simplify that if we want, as 13 is to the unknown RS. So when we set it up this way, we do our cross multiplying, and x equals 26. Again, you could have set this up multiple ways. You could have done the proportion as 25 over 50. It would have all worked out just the same. You could have set 13 over 25 is to x over 50. There's a lot of correct ways to do this. Just make sure that you're comparing comparable parts. So here we are again, looking at another one. And again, let's compare comparable parts. This one is asking me for the measure of FJ. So when I set up this proportion, what I want to do is I want to see what side corresponds with FJ. And the one that corresponds with FJ would be the side FG, which has a measure of 36. So I've chose to set up my proportion this way. So now we'll keep on going here. So since I chose FJ as my numerator, I need to keep it pretty consistent. So I'm going to pick a numerator from the same side, which is 24JI. Now make sure that you compare what you're supposed to be comparing, because a lot of times people are going to just jump to the number. Well, the number does not compare to what this is. What this is the extension of the small triangle. Well, the extension of the small triangle on over here is GH. Well, they don't give us what GH is specifically, but they tell us what the combination of these two is. This is 36, and the whole thing is 54. So the added part is going to be 54 minus 36, which tells us this is a measure of 18. So our ratio is going to be 24 is to 18. FJ is to 36 as 24 is to 18. Some of you are going to notice patterns, and that's fine. Kind of like 36 is double 18. So that means the other side's going to have to be double. If you don't, that's okay. We can set up our proportions, and we keep cross multiplying. (24) times 36 is 864. We would then divide by 18, and we already know it's double 24, which is 48. So the value FJ equals 48. As we take a look at this one, make sure that you recognize what they're looking for. I like to highlight these first. The first thing it says is find the measure of HJ. These lines are parallel. So this segment here is HJ. Well, you can do this numerous ways. I could try to set up a proportion HJ is to, on the other side, it's relatable to GJ, which is 30. So HJ is to 30 as the only other part that we have here. We could do the math eventually, but the only other part we have here that is comparable, we cannot use the 20 because we don't know the side that correlates with that. So if we can't use the 20, we obviously have to use the 10. Now, 10 is coming from the side over here, so 10 has to stay the denominator. I chose to make this side the denominator, so I have to continue that pattern as I go. So 10 is to 22. The only way you're going to mess this up is if you start putting parts that do not correlate together. So make sure you take your time and see that you are doing what you're hoping to do on these. So we multiply this side times 10, it's 10HJ. 22 times 30 gives me 660. We divide both sides by 10, and we should get 66. HJ is a measure of 66. Let's see if this scale factor works. 22, by the way, if this is 22 and the whole thing's 66, this would be 44, and that actually answers my question. Because our scale factor was a 2 to 1, and 22 to 44 is a 2 to 1. And this scale factor could ring true. And you may have set this up differently. As long as you're coming to the correct answer and you're comparing corresponding parts, you should be all right. Here we are again. We're looking for SU. It's this long segment here. So we need to find out what each of these are. I'm actually going to solve this one without line proportions. Let's take a look. On the other side, the XS, the QR, is double the segment over here. Or, half of the segment over here. Well, if that's the case, then we have a scale factor that correlates. So if this has a length of 8, this has a length of 16. You could have also set up a proportion, 5 is to 10 as 8 is to TU. But again, we're not looking for TU. What we're looking for is SU. And this is our segment addition postulate. ST plus TU will equal SU. So 8 plus 16 is 24. Our segment is 24 units long. I really like these. These are a little bit of a puzzle going on. This one, you'll see, is really just working back from the other one. We're going to end up with the same information here, but I just want to talk about how we can do this. We only have 2 sides here, but if this segment from here to here is 24 units, this segment here is 16. So what we have is a segment of 8 compared to a segment of 16 is a 2-to-1 ratio. It is a 2-to-1 ratio. So we're going to talk about how we can set this up. Now, some of you are pretty good with your arithmetic and you know what the 2-to-1 ratio is. Some of you may have a little bit of a struggle. So here's what we can do. We can still set up a proportion, but we're going to have to set it up with algebra. And here's what we're going to say. We're missing a side here, so we could say 24 is to 15 because that's the numbers we have, as 8 is to, and then what we're going to have here, if we called this segment X, QR, we could call, actually, let's not do it that way. Sorry, about to overcomplicate things. Let's call this segment X. By the way, we may get stuck on one where we have to do this. Well, if that segment is X, this segment UQ would be 15 minus X. But we have a proportion here. We have a scale factor, so we are able to do this. So we're just going to measure this out as X. So we cross multiply. This is 24X. And this is 120. So my value of X is 5. Now I wasn't paying very close attention, as you can see, because we were looking for QU. But we have this formula here, so that's okay. So we go 15 minus 5, which is 10, which is our final answer. What a smarter, more efficient move would have been is instead of picking X to relate to the 8, I should have picked X to relate to the 16. But you could see I still came out to a correct answer. I just had to do a little bit of extra work. So let's highlight what we're looking for first of all. VW. Well, VW relates to 34, so let's go ahead and set that one up. Now, we can choose what we want to do on this. Well, I want to go ahead and use a value I know. So VW is the bottom, so 8 has to be the bottom because they are the shared side there. So 8 corresponds with, on the other triangle, Vx. Well, Vx is not given to us, but we can figure it out because this segment is 51 and from here to here is 34. So the remaining segment is just going to be 51 minus 34, which is a segment of 17. And that is the portion that 8 corresponds with. So now we're going to do our cross multiplication. This gives me 272. This gives me 17 VW. Since I was smart enough on this one to set it equal to the one I wanted, I don't have to do any arithmetic after this. It's just VW equals 16. So in this one, we're still going to set it up like a proportion. 5 is to 2s plus 9, as 10 is to 2s plus 20. We still cross multiply. Both sides. Just like that. We'll have the distribution happening. And then after the distribution, we will just solve for s. So s equals 10, and that's all we were asked to solve for.